Similar triangles are similar in shape, but not size. So that means that all their angles are congruent, but their sides are proportional. And that's what this squiggle represents, is proportional. So here's an example related to similarity. Find all pairs of triangles that satisfy the definition of similar triangles. Also identify other pairs that appear to be similar. So the definition of similar triangles is that all three angles are congruent and all three sides are proportional. So we're looking for the three angles being congruent, which means they're going to have to be marked. So ABC with the angles marked, and the sides need to be proportional. So 8 to 16, that's double. 4 to 8, that's double. And 6 to 12, that doubles. So they are similar. If it goes ABC, it needs to go LKJ. So those are similar. Those are the only ones that have all the information we need. But it appears this one's pretty close. The angles are marked, and the sides are not marked, but it appears like it might be. So that one appears to be similar. This one not so much. It looks like that's a right triangle. It's not similar to the ones we have. NMO looks like it might be similar to HGI. It appears to be similar. Also, EDF looks like it might be similar to TSU. Make sure you write them in corresponding order. So let's go ahead and just write this one in our first statement. Triangle Q, no, RQP. There are shortcuts to showing two triangles are similar. First, if all three angles are congruent, then triangles are similar. But that also actually means a more powerful statement is if two angles are congruent, the triangles are similar. And it's more powerful because there's less information, but that third angle would have to be congruent because the angles of a triangle add to be 180. So if two angles are congruent to two angles of a different triangle, those triangles are similar. So in triangle ABC, DE is parallel to AC. If AB is 6, CE is 1, AC is 8, and BE is X, and BD is 4, find DE and BC. DE is this parallel segment. BC is the entire length of the right side of the triangle. So if triangles are similar, then we can write a proportion regarding their side lengths, because the side lengths would be proportional. So since DE and AC are parallel, that means we have corresponding angles congruent. So the triangles are similar. ABC and DBE are similar because of the angle-angle theorem. Since they're similar, we can write a proportion. We can do the left side of the smaller triangle over the left side of the larger, and set that equal to the left side of the smaller triangle over the right side of both, the right side of the larger triangle. Then cross multiply. If you want, you can reduce this first. 2 and 3. So we get 2x, we'd have to distribute 2x plus 2 equals 3x. Subtract 2x, we get x equals 2. So this side length is 2. It didn't ask for BE, it asked for the entire length BC, which would be 2 plus 1. So BC is 3. Also, to find DE, we'll set up another ratio. We can do left side of the small over the left side of the big, 4 over 6, equals the bottom of the small over the bottom of the big. Bottom of the small is what we're looking for. Bottom of the big is 8. So again, you can reduce. So we have 3x equals 16. Divide by 3, we get 5 1/3, 5.3. That's the length of DE, 5 1/3. Another theorem we can use to show triangles are similar is the side angle side similarity theorem. If we have two sides are proportional to the corresponding sides of another triangle, and the angle in between is congruent, that's enough to show the triangles are similar. So in figure 6.7a, AB is 7, BC is 10, and AC is 14. If DB is 5 and BE is 3.5. State which two triangles are similar. So we do have angle B. There are two triangles here, BDE and BAC. And angle B is in both of them, so it's congruent to itself by the reflexive property. And if we look at the sides, we have 3.5 on the right compared to 7 is not going to be, 3.5 to 10 is not equal to 5 to 7. But if we flip that and take 3.5 with 7, we'd have to double it, and 5 times 2 would get 10. So they are similar because they are proportional. Writing them in order would be triangle DBE is similar to triangle, then we have to start with this side, CBA. And then to find the length of ED, we've already found that the ratio will be 5 to 10 equals the side DE that we're trying to find. For right now, we'll just call it X over 14. Can reduce to 1/2, so we get 2x equals 14, so x equals 7, which is the length of ED. Two triangles are also similar if just all three sides are proportional. So in our example, DE and F are midpoints, which means it bisects the larger sides, it cuts them in half. Prove that triangle ABC is similar to triangle EDF or EFD. So to show that EFD is similar to ABC, we need to show either something about the angles being congruent or sides being proportional. Let's go ahead and look at their sides, since all the sides are being cut in half by these mid-segments. If we look at triangle EFC right here, angle C is in both EFC and BAC, and the two sides, BC is exactly double EC, AC is exactly double FC. So triangle ECF and BCA are similar. In fact, ECF is exactly, the side lengths are exactly half of their corresponding part. So that means EF is half of BA, which is marked with 2 ticks. We can apply that exact same reasoning and show that DE is exactly half the length of AC, which is marked with 3 ticks, and DF is exactly half the length of BC, which would be marked with 1 tick. But then we've basically already shown, just by doing that, triangle ABC, so that means AB is going to match up with EF, and EF is half that length, which we just mentioned. Same thing, DF and BC, so they are proportional, as well as DE and AC. So all the sides are proportional, so they are similar by side, similarity.